Now, here's a mini question that you might be asked in a system design interview. Let's say you have several machines in the data center. How do you efficiently copy data to several machines? So here's an example. Let's say that this is our source machine, and you have a bunch of different machines here. Now, they're all connected to each other in some network topology. You have this block of data that needs to be copied to every single machine. Now, the most naive way to do this is for the source machine, let's call this A, to send this data one by one to each machine. So it establishes a connection with this machine, sends it there, then it establishes a connection with this machine, sends the data there, and so on. But that's not very efficient because during this time, there's a lot more network bandwidth that can be used, right? This network bandwidth is just staying idle. So how do you improve this? Well, you would improve this by copying this data to the closest machine to A. The closer it is, the faster it will be. So let's say you copy this data to the closest machine and give this machine an instruction to copy to its own closest machine. And you do the same thing with this machine here. So at this point, machine B will start copying this data to machine D, while machine C will start copying this data to machine E. A's work here is kind of done. Using locality, which is copying to the closest machine in a data center, and delegating the copying to other machines helps you to really make this faster. Now, another thing to note here is, let's say, what if C had a connection to B and C tried to copy data into B even though B already has it? Well, B will just say, look, I already have it, so I don't need it anymore. And so this block will have some kind of an ID. And C will try copying this here, but B already has it, so it'll reject the request, and that's it. So this is a lot more efficient way to copy data to different machines.